Hey, everybody. I just wanted to take a second here to announce the section that we're going to be talking about today, abusing smart cities in the dark age of modern mobility. This is an especially interesting topic for me as I live in a city that is still stuck in the dark ages in Texas. I also want you to be aware of the fact that we've got full Matteo redundancy in this presentation, with not one, but two of them in case one of them breaks. So I'm going to turn it over to them.
So, thank you everyone for coming, and thank you for your time. We are going to steal you just 1 hour, so. Okay, I'm Matteo Beccaro. I work as in the security field as a CTO of a small company in Italy, and we do offensive physical security. That's my Twitter, and if you want to just give feedback at the end of the talk, I'd be happy to reply to that.
There's me. I'm Matteo Collura, and I got a bachelor just 2 weeks ago, and I'm still a student studying now in the field of nanotechnologies for ICTs. So if you want my Twitter as well, you find here my personal information. And starting from May, we are with Opposing Force, member of Securing Smart Cities, which is a non-profit organization which helps decision maker to consider also security issues when implementing new solutions. And I will give the speech to my friend that will start illustrating what we did.
Okay, so that's the agenda for today. We start giving a little overview about what a smart city is. Then we focus on a transportation system, smart transportation system. And what we want to do is like introduce a methodology for assess those kind of systems. And doing so, we also have 3 different case studies, one for each infrastructure in a smart transportation system. And we apply our method to these case studies. And then we see what's up next. So let's start with what is a smart cities. So a smart cities is usually composed by several critical infrastructure, as for example, energy management, surveillance systems, water management, transportation system, and waste management. So for a city to become smart, usually those infrastructures have to be connected in some way. They can be connected to some central system or connected to each other to communicate and, better manage the resources. In this presentation, we are going to focus on transportation system. So let's focus on smart transportation system. And a smart transportation system itself is divided in several infrastructure. And we may have traffic control, we may have a smart parking system, we may have a smart street lighting systems, and public transportation system. So it's pretty complicated to work in this kind of environment because we have multiple layers, multiple infrastructure, each one communicate with the others in unknown protocols. So what we are doing is trying to define a method to assess the system to easily doing so, because that's what we do for jobs. So we have to, do it as quickly as possible and the best way we can. So let's see quickly how a smart transportation system is usually composed. We have two different kind of systems. The first one, in which every element, so for example, traffic control system, smart lighting control, smart parking and transportation, communicates with some central system. Each central system then communicates to a more central system. And that central system aggregate the data from all the other systems and communicate information, usually useful information, to the citizen, like what is the best road to go to work, where is less traffic today, and so on. And another kind of system is where each of the macro system communicates directly to the user, and sometimes also directly to each other. So there is no need of a more central control system. Usually, the central point of a smart city is always the citizen. So all the infrastructure are thought to be helpful to the citizen. Okay, let's go even more in details. So, smart transportation system. We have private transport, shared transport, and public transport. With the private transport, we mean like smart parking. With the public transport, we mean metro, bus, tram, trains, you call it. And with shared transport, we mean the new transportation economy like bike sharing, car sharing, etc. I drink a lot, so sorry for these interruptions. Okay, that's one of the method, one of the architecture we use to assess the system. So we try to reduce every infrastructure to this schema, in which we have an edge domain, and inside the edge domain there is the edge device that take data from the physical world and send this raw data to a cloud domain. The cloud domain is like the brain of our system, and it, analyze the data and send commands back to the device, or send information to the client domain, which can be like mobile application for the citizen and etc. So the communication usually is always bilateral. So the edge devices can both send data and receive commands, so they can act properly about the data they are sending. So for example, if there is no traffic, the traffic light is always green. Okay, that's that's a little bit introduction. Now let's go to our first case study, a smart parking meter system. We will show some vulnerabilities about that. Okay, that's the device. Let's make a little bit of introduction about how the device works. So the device is bought by the user at some shop, and then the device can be recharged, so you can store credit on the device, and you can do it both online from your home. So you connect the device to your computer, register on the website of the company, and then using your credit card or PayPal or whatever, you can charge credit on the device that can be used later. Or you can do the same procedure at some shops. So you go to the shops, you gave the device, you pay in cash, and the guy can charge your device. Once the device has some credit, you can park your car and then turn on the device. You then have to select the proper location, because this device is available for more than 40 cities in Italy. Actually, I shouldn't say Italy. Okay, in more than 40 cities worldwide, and it's growing. So you have to select the correct cities, because each city has different fare zone. And once you select the city, you have to select the proper fare zone and activate the device. For now on, every second, the device automatically calculate the fee you are paying and reduce that amount from your credit. So actually, the benefit for the user is that the user doesn't have to bring like coins and cash to pay the parking, and he just pay for the exact time is parking, and not for like half an hour or 1 hour over. So these are some of the interfaces we found on the device. So there is a display port, which is used for showing some information we will see later. There is the USB port, which is used to connect the device through the so-called gateway, which is our computer that connects the device to the cloud system. And then we have our MCU. All those interfaces have some vulnerabilities. We will solve them in a few. I just need to drink again. At DEF CON there is the first time you speak at DEF CON, they usually bring you shots of alcohol. They didn't do that this year. I don't know why. This is
Ask yourself.
yeah. Anyway, the first analysis we did on the device was a firmware analysis, in which we found that there were no integrity checks. The firmware can be easily obtained in two different methods. We can intercept the communication between the gateway, so our PC, and the backend system during an OTA update. So we can intercept the firmware, or we can extract the firmware directly from the MCU. In both cases, unpacking the firmware was easy, and no integrity checks were present, no encryption in the firmware were present, no obfuscation, and no authenticity authenticity checks is present during the firmware upgrade analysis. So the result is that attacker can upload a malicious firmware, for example, removing the reducing of the credits part. So you can turn on the device acts as it always been, but at the end of the day, you have always the same credit on the device. As I said before, there is some debug interface. Sorry, there is some debugging interfaces present on the device. We use the JTAG port and the SWD port to extract, for example, the firmware. There are also other debug traces for all the components. So for each component present on the device, you can actually intercept the data, exchange it, and inject other data. So let's try to reconduce our device to the schema I showed you before. So for the edge domain, we have the parking meter, which is connected via USB to our gateway and to the cloud domain. The cloud appliance is used for like remote charging the device to create invoice based on where you park and how time you park, for example, for expensive for the company, etc., and to do OTA updates. So the cloud domain then communicates to a client application, which is gave to the inspectors. The inspector can use the application to check if you are paying the correct fee for your staying, if you are paying correctly. Another thing, usually the inspector check if you are paying correctly just by looking at the display of the device. But there is also an NFC interface that the inspector can use to access memory on the device. So we did a communication security analysis, and the result were that there is no data validation between the edge device and the cloud domain. So we can both modify the data sent from the cloud to the device and from the device to the cloud. And moreover, all the trust in if you are paying or not is in the device itself. So the inspector can actually check only if you are paying by looking the device or accessing the memory on the device. It cannot check if you are paying correctly using the cloud data, because the device it's not updating its status in real time. So as I said, there is no integrity check, no encryption, no authenticity checks. So this is a sample request we intercepted, and from that you can see, I don't know if you can see, but there is some parameters which are very useful, and this is a configuration file. So every time you connect your device to the gateway, the cloud appliance sends new configuration files for updating like fee zones, etc. If there are any new cities, and we can modify that configuration file. Okay, so reversing the firmware, analyzing the communication, and using some debug interface to understand better the data, we finally found what is the formula used by the device to calculate the fee. That's the formula. So we have the price per time unit, then we have the fare frequency, because in some cities you may have to pay every half an hour and not an hour, so it's another parameter. Then we have the seconds elapsed from when you turn on the device, and then you divide all this for 1 hour, because usually it's 1 hour. And then we have to add the minimum fee, because in some parking you have to pay at least 1 hour of parking, even if you stay just for like 10 minutes. So, as I said before, when you turn on the device, the display shows you the price you are paying and the time you turn on the device. So those two parameters are actually displayed. So even if we modified the configuration files, so for example, if we put at 0 the price per time unit, that 0 is displayed by the device. So the inspector can actually see you are committing a fraud. So that's not good. The minimum fee in all the cities at the moment is usually set to 0, so we don't have to care about that. So what's the only parameter we have to change to set the multiplication to 0? Because that's what we want. If we set the multiplication to 0, then our fee is 0. So if you can change the fare frequency to 0, all the formula is then 0, so we don't pay anything, even if the correct configuration files is displayed, because price per time units, we just set the correct one, and the second, we don't modify that. The fare frequency is not displayed, so we can change it easily to 0 from the configuration file. So we intercept the configuration file, change the value to 0, and then the old formula becomes 0. So that's why we call our formula our centogral. And using this vulnerability is pretty easy to exploit. We actually wrote a little script that can allow you to do everything automatically. So you can just plug the device to the computer, and I don't know, maybe 3 or 4 seconds, your device is every city present in Italy or not. Actually, you pay 0 for parking. Moreover, we also develop a firmware in which the fee payment is removed. So we display the correct information, but we don't remove the credits from the memory. So multiple vulnerabilities allow you to actually not pay for parking. That's a good thing, right? Okay, I'll now leave the word to my colleague, which will talk about the next 2 case study.
Okay. Oops. Okay. Spoiler. Yeah, a little spoiler, but we will go on speaking now about shared transportation systems, and in particular we will speak about bike sharing. Well, our case of study was divided into 3 steps, essentially. The first step is the one in which you go to the station where all the bikes are located, and you unlock yours. The second step is the funniest, you ride the bike. And the third one is when you lock it again and you walk away. So let's go step by step from the first one. The first one, the picture shows that the ways to unlock your bike are essentially 2. The first one is, say, more physical. You need an NFC card, and the NFC card will be checked. Here we will see how. Will be checked and will unlock the bike. The other way to unlock is by using a mobile application on our mobile device. So the station is speaking with the cloud, or with the backend, that authorizes the unlocking of the bike. Let's see more in detail. This is one of the stations. And as you can see on the top, there is a NFC reader for the card. And as I said before, there are those 2 accessible methods in order to unlock the bike. Let's focus on the first one, so the mobile application. So at first we decompiled the app, and we found that there is no obfuscation on the code, and so that helped us a lot in order to understand how the whole procedure works. But moreover, one of the critical points is that the vendor credentials are coded, and obviously we obfuscated them here because we don't want to say the name of any company here. And the critical point is that with those credentials, you are allowed to create new users, charge some credits on those users, activate the users, and unlock a bike in real time, wherever it is. So it is quite dangerous, I mean. And moreover, there are some APIs here and that are vulnerable to SQL injection. And of course, for legal reasons, we did not make any attempt to exploit them. So I will skip this part. And
There is a private Q&A session later.
Let's move to the card analysis. Okay, I hope you don't recognize the city, but it's okay. Let's go on. It's in Italy, but she said before, and that's
It's
my
not.
second the second mistake. Okay, it's a ultralight NFC card. So we all know that ultralight does not have any encrypted data on it. The protocol is not encrypting the data inside, so each one can read it easily. And there is no authentication while reading the card. So if I can get one of those cards, I can easily read with my smartphone or another reader. And the only identification parameter in it, unique identification parameter, is the UID, which identifies one and only one user. So that is all the sensible information relies in the UID to unlock the bike. And if you look closely to that card, just look inside that rectangle. I don't know if you see that number. Please raise your hand if you guess what that number is. Please do. Yes, you're right. It is the UID, but in reversed way. So, don't know who decided to put in that place the UID. Well, of course, it is simple to read it by a reader, but they ease you this procedure. Let's go further and analyze the other steps. Well, there is a physical issue we found in the stations, because the only way the station is able to understand if the bike is properly locked or is inserted is by a sensor inside that little piece of metal you see in the hole. And if you slightly remove the bike as soon as you unlocked, but just a few centimeters, if the distance is short, the sensor will not, the station is not going to understand that the bike has been removed. And so after a minute or 30 seconds, I don't remember, the unlocking process goes in timeout. And the station locks again the bike. The point is that the bike has slightly been unlocked. So the lock is not locking actually the bike. And you can extract the bike, and the station will feel as if the bike has not been unlocked. And the point is that the central system can detect this issue in two ways. The first one is that you leave the bike in another station. So the central system will see, okay, I have the bike number 123 in station 1 and at the same time in station 2. So there is something wrong. And the other critical point is if there is another bike that is going to be left in that station, the central system will understand that there are two bikes in the same location, so it is actually a problem. And that's all for the shared transportation systems. And what about the public transportation systems? We defined two different architectures. The first one we called the offline system, because each of the bus, metro, or tram, however, they are speaking with a backend, and the backend is unilaterally speaking with a UID blacklist or a database, which is recording all the possible tickets that are run out or banned, don't know. And the other architecture is we call the online system, because the difference is that the UID blacklist can interact with the stamping machines that are located on the bus, metro, or whatever. So let's start with the first architecture. We spot out two main vulnerabilities. The first one is called lock attack, and actually it's quite easy to be understood. because the sector where the writes are located, it is the OTP one, can be made read-only if we set 1 bit in the lock bytes to 1. So it's quite easy hack, let's say. And no writes will be removed when you stamp your ticket because it is read-only. So essentially, it's quite easy also to be fixed, this vulnerability, but it will work. Essentially, well, it was working. And the second one we are talking about is the time attack. And this is nicer because you don't have to make any modifications to the lock sector and to the OTP. So you leave essentially all the writes as they were, and you find the place where the timestamp of the last validated ticket is stored. So the only task is to reverse the timestamp and find the initial time when they start counting the minutes. So as soon as we reverse those data, for example, here we put a rectangle, a red rectangle around that area, and we found the initial date was something around 2005. I don't remember.
1st January.
Yeah, don't say it loudly. And we found that, and so that way we are able to forge our own timestamp and validate our ticket without touching the writes, because the ticket is valid for some minutes, 90 minutes or whatever, and so you will have always a valid ticket. And what about the online systems? Those kind of systems are not vulnerable to the previous, but are vulnerable to the replay attack. Well, offline systems are also vulnerable to replay attack, but I will explain now. And by replay attack, you have a lot of possibilities and will be a serious problem. Because if you use some emulators or clone tickets, the one from China, for example, there are no rules. They act like MIFARE Ultralight, but they are not, or other MIFARE, maybe Classic, etc., but they are not following the standard rules and the protocols. They are completely erasable and changeable. So you are allowed to change the UID, forge new UIDs with a valid structure, because you can clone your ticket with a valid structure, even if it is encrypted. You change the UID and then you can stamp it and bypass any software encryption, because the validating machine makes everything by itself. And moreover, you can also use the same ticket you clone it on your clone one, you increase one ride, and you stamp the clone one, and then you come back to the previous ticket, the original one, copying all the data sectors and whatever you have, so it will be perfectly indistinguishable from the previous one, and it is valid. And the problem is that the implementation of a whitelist would be a problem in our systems, because the whitelist must be updated on all the stamping machine in real time. Think about if you go to buy a new ticket from a shop, that ticket must be usable immediately as soon as you buy it. So the implementation of a whitelist is a serious problem, and it will mean, well, you will need to build a completely new infrastructure if you already deployed one to implement such a thing. So it will be a very, very difficult task. As regards future works, what's next? Well, we studied, this is the picture we see before, and we spoke about energy management, surveillance systems, water management. So let's start with smart cities surveillance. And those kind of cameras can be used for, well, they have multiple uses. One of those uses can be for policemen to charge people maybe going with their car in restricted areas, for example, limited traffic areas, and they can snap a picture of your plate and sending you a fine for entering that. But how is the connection made between those cameras and the main backend? Well, we still have to understand how. And then we have something on water management. Maybe there are some counters that are revealing how much water each one of us is using, and applying a charge for each cube meter of water. I don't know if you use here those kind of units of measurements, but the amount of water you need. Yeah, imperial is different from metric, but I hope it is clear the same way. And so those kind of systems have to be interconnected between a central infrastructure that evaluates the right fee to be charged at each user. But what about, for example, the smart city lighting system? And this way we are going to illustrate, for example, how the lighting for a street maybe, or some buildings, how to save money in turning on or off lights when it is not necessary. So what is the algorithm a central system can use to turn on or off those kind of lights? That it will be a central point for future works. And finally, the smart traffic light system. Some new technologies about making the green light last longer if the road is quite crowded, and maybe preventing from turning it red if there is no car in the crossing road. And but if those systems are interconnected and badly, let's say badly, and the connection is not secure, maybe an intentionate user can turn the red on and the green on and the green on the other side. Could be a mess.
Yeah, there was a paper published by Cesar Cerrudo about traffic system. You can check about that. It's
yes.
Interesting thing.
On securing smart
securing smartcities.org.
Yeah. And finally,
one of the we can test all those infrastructure, but our final challenge will be hacking a whole city.
Yeah.
So, as you saw, we have like material for free or for DEFCON. So we're good to go. You can see us in the next year, probably.
Sure. And if you have some
cities,
you would recommend some cities to be hacked?
Yeah,
and
we are.
Want to sponsor us? We are. Yeah.
You just need to play the flight, a 5-star hotel, and then we can work something out. No problem.
You forgot the suite.
Yeah, 5-star. Suite in a 5-star hotel. Yeah, sorry. One each. We don't share.
Okay.
Just to be clear.
Yeah, sure.
Okay, so I think there is like something like 1,500 people now here. Any question?
Don't be shy. Come on.
It's written. Don't be shy. It's a Q&A session.
There.
Okay.
Do we have a microphone for?
How does it work?
Yeah.
Goons, we need a microphone.
Goons? Not here. The microphone is here.
Oh, okay. You have to come here. You have to do the work.
So on a replay attack, rather than copying it to another device, couldn't you just copy it, make a gold image, and then after you've used it, replay that back onto the original device?
Yeah, you can do that, but the problem is when you have the blacklist, sometimes your ticket can be put on the blacklist because it actually behaved in a not correct way. So what we did is to inject new UID. So the system doesn't recognize if every time you stamp the ticket, you put a new ID. So this new ID has not previous behavior, so they don't ban it. Other question, just stand up and go to the microphone.
Yeah, okay. No questions? Come on.
We have like
Yeah, still
more or
10
less.
minutes.
Yes. So we won't go anywhere.
Please ask.
You have to stay inside. Close the doors. Okay, thank you.
I have a question.
Thank you.
It's for you, not for us.
For me or for you? I can talk afterwards. It's fine.
Thank you.
Singapore is having a real big surge with their Smart Nation. One of the things that they're doing is they're having a big push for, in the name of elder care, monitoring in the home. Are you seeing that in Europe?
Nope. At least not in Italy. Well, we are from Italy now. Maybe you have understood that, but not in Italy. It's an interesting thing because we actually never thought about that. But we are going to present the same research in Singapore next month at GSEC. Yeah,
2
this
weeks.
month.
2 weeks.
At the end of the month in GSEC. So maybe there's some like interesting point to speak about.
Can you tweet where you're doing this information? Because I live in Singapore. I'd like to attend.
Okay, you can come later and give you the link and whatever.
So on the parking meter charge hack, did you think to try making the charge negative?
Yeah.
Yeah, but
And something very weird happened.
yeah,
They charged us like 10 times what we owe.
Oh,
yeah. So there must be something more in that formula.
Okay. Reversing the firmware, there is some like very strange things, like some weird vulnerabilities in which you can like overflow the whole system and crash it. It's,
more to look into.
but yes, we tried.
Hi, so in Chicago we have a different bike share system with a different lock at the front of the bike, which I believe, I'm not sure if this hack will work or not on it. So I'm wondering if you've looked into other hacks for bike share that aren't reliant on the locking mechanism. And then also our bikes have GPS, so have you figured out how to, if you wanted to literally steal the bike, how do you overcome the GPS?
So you have GPS on the bike.
The bikes.
Okay, there was a talk, I think last year at Black Hat, or DEF CON, or both probably, about spoofing GPS data with the SDR. So you can actually bring your SDR in a backpack with a battery and like spoofing the data and meanwhile stealing the bike legally. It's a principle we are trying also to apply to car sharing because they check your mileage and where are you going and they charge money for that. So it's interesting thing. You're welcome. Anyone else? 3 minutes.
Yeah. Maybe 4 or 5.
Okay. Thank you very much for coming. Thank you for your hour.
Yeah. Thanks for.
We really appreciate.
Also, thanks to all our sponsors, and yeah, that's it.